Students, welcome to new session. In this session we will start with a new lesson, some applications of trigonometry, heights and distances. In this lesson we will see the following topics, that is certain definitions related to heights and distances. The second topic will be problems involving one angle of elevation and problems involving one angle of depression. The third topic will be problems involving two angles of elevation. Third topic will be problems involving two angles of depression. And the fifth topic will be problems involving one angle of elevation and one angle of depression. Let us start with the first topic, certain definitions related to heights and distances. Here is the first topic, the line of vision. A girl is standing on the ground and there is a tower, and the girl is looking at the top of the tower, and therefore the top of the tower will be an object. And this girl is looking at the top of the tower, then the line drawn through the eyes of the observer, observer is a girl, means the line drawn through the eyes of this girl to the point on the object is called as the line of vision. So we can define the line of vision as it is the line drawn from the eye of an observer to the point in the object where the observer is viewing the object. So this is the line drawn from the eye of an observer to the point in the object where the observer is viewing is called as the line of vision. Now the second definition is the horizontal line. A girl is standing on the ground and she is looking straight, and a line drawn through her eyes which is parallel to the earth's surface is called as the horizontal line. So this is called as the line of horizontal. So this is the horizontal line. It means when an observer looks straight, which is parallel to the earth's surface, then this line formed is called as horizontal line. Therefore we can define the horizontal line as it is the line drawn parallel to the earth's surface through the eye of an observer looking straight. Now let us see the another definition, that is angle of elevation. In the first case we have seen that a girl standing on the ground looking at the top of the tower, then a line drawn through her eyes to the top of the tower is called as the line of vision, and the straight eyesight, this is called as the horizontal line. And so the angle formed by this line of vision and the horizontal line is called as the angle of elevation. So the angle of elevation is an angle which is formed by a horizontal line and the line of vision. Here you have to remember one important thing, that whenever there is an angle of elevation, that object lies above the horizontal line. Here the top of the tower that lies above the horizontal line, and therefore the angle formed is an angle of elevation. Therefore angle of elevation can be defined as the angle of elevation of an object is formed by the line of vision with the horizontal when the object lies above the horizontal level. So the important thing is that when the object lies above the horizontal line, then the angle of elevation is formed. Now here is the another definition, that is angle of depression. So here is a boy standing on the ground and there is a ball on the ground, and this is the horizontal line. This line is parallel to the earth's surface and which passes through the eye of an observer. And if this boy is looking at the ball which is lying on the earth's surface, then this line is called as a line of vision, and the angle formed by this horizontal line and the line of vision is called as the angle of depression. So here important thing is that the angle of depression is formed when the object that lies below the horizontal line. Therefore the angle of depression can be defined as angle of depression of an object is formed by the line of vision with the horizontal when the object lies below the horizontal line. So when the object lies below the horizontal line, then the angle that is formed by the horizontal line and the line of vision is called as the angle of depression. Students, now start with the first type of questions, that is problems involving one angle of elevation. The first question is the angle of elevation of the top of a tower from a point on the ground which is 30 meters away from the foot of the tower is 30 degrees. Find the height of the tower. Friends, here AB is the height of the tower and there is a point C on the ground, and the distance between this point C and the foot of the tower is given as 30 meters, and the angle of elevation of the top of the tower from the point C is 30 degrees, and we have to find the height of the tower. Here if you see, you will find that the angle of elevation is 30 degrees, tower is the opposite side, and this 30-meter distance is adjacent side. So we will have to search for such a relation which contains the opposite side and the adjacent side. So in triangle ABC, tan of 30 is equal to opposite side upon adjacent side. Tan of 30 is 1 upon root 3, which is equal to opposite side is AB, that is the height of the tower, and adjacent side is 30 meters. And therefore AB, if you take 30 to this side, AB will be equal to 30 by root 3. Now here we do not write search in the denominator, so we will rationalize this. So AB is equal to 30 by root 3 multiplied by root 3 by root 3. Since we are multiplying the numerator by root 3 and the denominator by root 3, it means we are just multiplying by 1. So after solving this, we get AB is equal to 30 root 3, multiply the numerators, upon root 3 into root 3, that will be 3, and so it will be 3 1s are 3, 3 10s are 30. so which is equal to 10 root 3 meter, and therefore the height of the tower is 10 root 3 meter. Here is the next question on the screen. A kite is flying at a height of 60 meter above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degrees. Find the length of the string assuming that there is no slack in the string. Students, here a kite is flying at a height of 60 degrees above the ground, and a string is attached to the kite is temporarily tied to a point on the ground. So here a string of the kite is tied to the ground and the angle of inclination is given as 60 degrees. So let this point be A, this point be B, and this point is C. Now here we have to find the length of the string. This is the angle of inclination, and this is the opposite side, and this is the hypotenuse. So we will have to search for such a relation which contains opposite side and the hypotenuse. And so in triangle ABC, sin theta is equal to opposite side upon hypotenuse. So sin 60, that will be equal to opposite side upon hypotenuse. Here the opposite side is 60 meter and the hypotenuse, that is the length of a string, that is AB. Sin 60, that is root 3 by 2, so which is equal to 60 by AB. We will take AB to this side, root 3, and 2 to other side. So it will be AB is equal to 60 into 2 by root 3. So AB will be equal to 60 to the 120 by root 3. Again here we do not write surds in the denominator. To remove this surds from the denominator, we rationalize. So multiply by root 3 to the numerator as well as denominator. So it will be AB is equal to 120 by root 3 multiplied by root 3 upon root 3. So the numerator will be 120 root 3 upon root 3 into root 3, that will be 3. So it will be 3 4s are 12, 3 zeros are 0. So AB is equal to 40 root 3, and therefore the length of the string, that is equal to 40 root 3 meter. Here is the next question on the screen. In a violent storm, a tree got bent on the ground, on the wind. The top of the tree meets the ground at an angle of 30 degrees at a distance of 30 meters from the root. At what height from the bottom did the tree get bent, and what was the original height of the tree? Here let AB is the original height of the tree and C is a point where the tree touches after bending. So let D is a point where the tree bends and it touches the point C, and it is given that the distance between the root of the tree and the point C where the tree touches is 30 meter, and the angle of inclination is 30 degrees, and we have to find the height at which the tree breaks and the original height of the tree. So here first we will take the triangle DBC. We have to find BD, and that is the opposite side, and the adjacent side is given, that is 30 meter, and so the relation between opposite and adjacent is given by 10. So in triangle DBC, tan 30, we know that tan theta is equal to opposite side upon adjacent side. So tan 30, that will be equal to BD upon 30. Tan 30 is 1 upon root 3. So which is equal to BD upon 30. So 30 we will take to other side. So it will be BD is equal to 30 upon root 3. Multiply the numerator and denominator by root 3 to avoid surds in the denominator. So it will be BD is equal to 30 root 3 multiplied by root 3 by root 3. And therefore BD, that is equal to 30 root 3 upon root 3 into root 3 will be 3. 3 tens are 30, and therefore BD is equal to 10 root 3. So the height of the tree at which it bends is 10 root 3 meter. Now we have to find the distance DC also, because we have to find the total height, because DC and AD are of same distances, and therefore AD plus DB, that we will get the total height of the tree. So here in triangle ABC, again in triangle DBC, we have sine 30, that is equal to opposite side upon hypotenuse, that is DB upon hypotenuse is DC. Sine 30 is 1 upon 2, so it will be 1 upon 2 dB upon DC. So DC is also given to us. Here we have to find DC. So 1/2, which is equal to dB, the length of dB that we have got previously, that is 10 root 3 meter. So replace it by 10 root 3 upon DC. So DC will be equal to 20 root 3. So this distance is 20 root 3. This distance is 10 root 3. Since this distance is 10 root 3, this distance AD2 will be 20 root 3. So the total height of the tree will be 10 root 3 AB will be equal to 10 root 3 plus 20 root 3. So AB will be equal to 30 root 3 meter. So total height of the tree, that is equal to 30 root 3 meter. Now the next question is, the angle of elevation of a ladder leaning against a wall is 60 degrees and the foot of the ladder is 9.5 meter away from the wall. Find the length of the ladder. Students, here AB is a wall, it is the height of the wall, and a ladder is leaning against it, and BC is the distance between the foot of the ladder and the foot of the wall, and it is given that this distance is 9.5 meter and the angle of inclination is given at 60 degrees, and we have to find the length of the ladder. So here in triangle ABC, BC is the adjacent side, AC is the length of the ladder and angle of inclination. So we will have to search for such formula where the adjacent side is there and the hypotenuse is there. So in triangle ABC, cos of 60, that is equal to adjacent side upon hypotenuse, because we know that cos theta is equal to adjacent upon hypotenuse. Adjacent side is BC upon hypotenuse is AC. So cos of 60 is equal to 1 upon 2. Since cos 60 is 1 upon 2, replace it by 1 upon 2, which is equal to BC. BC is 9.5 meter, so it is 9.5 upon AC that we have to calculate. So AC, that will be equal to 9.5 multiplied by 2, and which is equal 9 to the 18, and it will be 19 meter, and therefore the length of the ladder AC, that is equal to 19 meter. Students, we will stop here, and in our tomorrow's lecture we will see the problems involving in one angle of depression. Thank you very much.